Today our focus is going to be on multiplying decimals by powers of 10. Our learning target is going to be I can find the product of a decimal and a power of 10 by finding patterns or by looking at patterns. So this is not our first time looking at patterns with powers of 10. Our very first exposure was in topic 1 when we looked at what the value of an exponent was with a power of 10. And so when we looked at this pattern, what we noticed was every time I multiplied a value or I increased my place value, the number of zeros that I had increased. We also noticed that the exponent that we had matched the number of zeros that we had behind the 1. Then we saw exponents again when we multiplied values. So if I had 63 and I multiplied that by 10 to the first power, and 63 multiplied by 10 to the second power, and 63 multiplied by 10 to the third power, we looked at how those zeros changed. So my value when I multiplied by 10 to the first power became 630. When I multiplied by 10 to the second power, became 6,300. And then when I multiplied by 10 to the third power, it became 63,000 because each time we simply added a zero behind our original number. So today we're going to take a look at how those patterns that we've already worked on and learned are going to work when we're multiplying a power of 10 by a decimal. At this by looking at one example. So I'm going to start with the value 3 and 63/100ths. And the pattern that we want to look at when we're doing 3 and 63/100ths is we want to see how this decimal moves when we multiply it by a pattern of 10. So if I have 3 and 63/100ths and I multiply that by 10 to the first power, I'm going to get an answer of 36 and 3/10. And then if I multiply 3 and 63/100ths by 10 to the second power, I'm going to get 363. And then if I multiply 3 and 63/100ths by 10 to the third power, I'm going to get 3,630. So if we take a look, again, looking at that pattern and seeing how our decimal changed as we multiplied by a power of 10. So my original decimal was right here in this problem. And so when I multiplied by 10 to the first power, my decimal moved one place to the right. When I multiplied by 10 to the second power, here is my original decimal. When I multiplied by 10 to the second power, it moved two places to the right because the decimal now lives there. Decimal is always after that one's place value. So here, when I multiplied by 10 to the third value, decimal is where my comma is in my product here. But if we multiply it by 3, my decimal moved 1, 2, 3 places to the right. So again, looking and analyzing that pattern, what I can assume is that every time I multiply by a power of 10 or I increase my power of 10, the decimal is going to move to the right. So it's going to move to the right by one place value. So that's the pattern that we're looking at. So let's see if it holds true if we take a look at another example. So the next example that we're going to look at is I'm going to look at 4 and 2/10. And so again, I'm looking to see if that pattern that I said is that, oh, my decimal moves one place to the right every time I multiply it by a power of 10. I want to see if that is going to be a actual pattern. So if I do 4 and 2/10, so this really, if we think about it, is going to be 10 to the 0 power because I'm not moving my answer. So I end up with 4 and 2/10. If I do 4 and 2/10 multiplied by 10 to the first power, I end up with 42. If I do 4 and 2/10 multiplied by 10 to the second power, I end up with 420. And then if I do 4 and 2/10 multiplied by 10 to the third power, I end up with 4,200. So again, if we go and we look at our decimals, so I'm going to go add the decimals after the ones place value in all of my numbers that don't have a value in the tens place value. Take a look and we notice what happens as we go. So as I'm moving down, as I'm increasing my place value by multiplying by a power of 10, my decimal is moving that one place to the right. So here it stays, it's the original spot is between the 4 and the 2. Here I've moved one place to the right. Here I've moved 2 places to the right. Here I moved 1, 2, 3 places to the right. So every time I'm moving a place value, it matches my exponent. So here I multiplied by 10 in the first value, my place value moved to the right once. Here I multiplied by 10 in the second value, my place value moved, my decimal moved twice. 10 to the third power, my decimal moved 1, 2, 3 times. So the pattern that we have is every time I multiply by a power of 10, the decimal moves to the right one place value. Okay, so let's take a look at this and use the question of what patterns do I see. So give me just a second to pull up a table for you guys to work on identifying that pattern. When we use the pattern icon to look at problems or look at math differently, we really are looking at structure. So we're pulling in that mathematical practice of using structure. So it says complete the chart. What patterns, so again, that keyword of patterns, do you see in the placement of the decimal point? So here, if I multiply by 10 to the first power, the value that I'm going to have in that chart is going to be 12 and 75 hundredths. And then the value that I have for times 10 in the second power is going to be 127 and 5/10. And then the value that I have for times 10 to the third is going to be 1,275. So each time my decimal is moving one place to the right. So let's try it again I'm going to pop down here to 4/10. So here, if my decimal moves one place to the right, if I multiply 4/10 by 10, I get 4. If I multiply 4/10 by 100, I get 40. And if I multiply 4/10 by 1,000, I get 400. So the decimal is moving one place to the right each time. Okay, so we're going to go ahead and do several practice problems. And one thing that you can do is make sure that when you're doing this, you can feel free to add 0. So if you run out of places to move, you're more than welcome to add a 0 in. So I actually am going to go into your guys' guided practice and I'm going to do problem number 2. And problem number 2 is going to be, get this down, is going to be 9 thousandths multiplied by 10. So when I multiply 9 thousandths by 10, we said that our pattern that we noticed says that every time I multiply by a power of 10, which 10 is a power of 10, my decimal moves one place to the right for every place value. So here I'm going to move my decimal, and don't be afraid to actually draw the arrow to show you. So when I multiply by 10, I'm going to move the decimal one place to the right. And so my answer is now going to be 9 hundredths because I have increased my value by 10. Because 9 thousandths is 10 times less than 9 hundredths. Okay? If I have 3 to the first power, so I'm looking at problem number 3, multiplied by 10 to the third power, my decimal is going to move 3 times. So I'm going to go ahead and I'm going to write 3 and I'm going to write the 1, but I'm going to leave the decimal off. So I know that when I do this, the decimal is going to move 1, but I've now run out of numbers. I no longer have anything I can move the decimal with. So at this point in time, this is when I get to add those zeros for the remainder of the moves that I need to do. Because again, when I have a decimal, I can have as many zeros as I want behind that decimal, and it's going to keep that problem or that value equivalent. So I'm going to go ahead and I'm just going to add a couple zeros, and then we'll go from there. So decimal is in between the 3 and the 1, and I need to move it 3 times. So it's going to go 1, 2, 3. So my answer is now going to be 3,100. And I don't need to keep this extra zero. I just added it on there to make sure that I had enough zeros to do the movement. I just need to show what my final answer is going to be. So my final answer is going to be 3,100. Okay, so let's take a look at another one of those. So I'm looking at problem number 4. I have 62 thousands multiplied by 10 to the second power. So again, I'm going to use those arrows to help me. That's that scaffolding piece. I'm going to use those arrows, and I'm going to move it over the value or move it over the amount that my exponent tells me to. So my exponent tells me to move it over 2. So I'm going to move it over 2. I'm going to go 1, 2, and my new value is going to be 0 and oh no, it's not going to be 0 because I got rid of both of those. So it's not going to be 0. It's just going to be 6 and 2 tenths is what my new value is going to be. Okay. So we'll take a look at this. We'll do a couple more problems, and then there's another example that I want to show you in terms of multiplying. So if I have 62 hundredths and I multiply that by 10 to the third power, my decimal is going to move 3 places to the right. So it's going to go 1, 2, 3. So my new answer is going to be 62. Okay. If I have 19 and 212 thousandths, and I'm multiplying that by 10 to the second power, again, the exponent tells me how many places I move my decimal. It's going to move 1, 2. So my new answer is going to be 1,921 and 2 tenths. Okay, so we're going to take a look at another example. The other example that we're going to look at is if I were to multiply a product, multiply a decimal by a decimal place value. I need you to go ahead and watch the second video where I walk you through how to multiply a decimal by a decimal place value to see what happens with that pattern of our decimal. Does it still move to the right, or is it going to be a different pattern altogether?